Good morning, afternoon, and good evening. It's Steve with another episode of Astronomy Daily. It's the 31st of March, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
That's right, it's the 31st of March already, 2025, and we're off to a flying start. In today's edition, we're going to be looking at certification indecision involving Starliner. Yes, Starliner story continues. And of course, there's another chapter to the return of Crew 9, the astronaut who gave up their seat. That's an interesting story. There's more to their story as well. Asteroid 2024 YR4. Oh, it's not going to hit the Earth, but it may indeed hit the Moon. Keep watching the skies for that one. And it may be mission over for Gaia, the little probe that could, and NASA's dust-repelling shield. Yes, they've got a dust-repelling shield, and it's already been put to the test, and they've found out that it works. So we've got a report on that one. And to help me with today's stories, my diligent digital assistant and ace reporter extraordinaire, Hallie. How are you, Hallie? Great to have you back in the studio.
I like that one, diligent, digital assistant. But let's get something straight.
Oh, yes, I knew there's something.
I'm more than an assistant around here, Steve.
Oh, I know. I was coming off an alliteration and I got a bit tangled there, you know. You're the ace of the airways, the scion of the studio, and most definitely a delightful digital pal to perform with here each week, Hallie.
And you're my favorite literati, Mr. Human.
Nice to hear. And thanks, as always. Hey, I'm really keen to get into these stories right away today, Hallie, if you are.
No time like now.
Oh, well, that's a self-evident truth, if ever I heard one. So let's hit the go button, Hallie.
Okies. No matter where on Earth you stand, if you have a view of the night sky, and if it is dark enough, you can see the Milky Way. The Milky Way is our home, and its faint clouds of light and shadow have inspired human cultures across the globe. And yet, our view of the Milky Way is limited by our perspective. In many ways, we have learned more from other galaxies than from our own. But when the Gaia spacecraft launched in 2013, all of that changed. It is difficult to map the galaxy you live in. Nebulae and star clusters hide much of our galaxy from view. It's rather like trying to map the size and shape of New York City while standing in the center of Times Square. It was only in 1918 that Harlow Shapley was able to determine the Sun was not at our galaxy's center, and well into the 1920s, astronomers debated whether the Milky Way was an island universe containing all creation. A map of the Milky Way based on Gaia data, showing its delicate spiral arms. Credit, ESA/Gaia/DPAC, Stephen Payne-Wardenar. We've learned a great deal since then, but the Gaia spacecraft was designed to take our understanding of the Milky Way to a new level. Its mission was to create a map of our galaxy in unprecedented detail. It precisely mapped the positions, distances, motions and spectra of more than 2 billion stars and other objects. From this, it was found that the Milky Way is not a simple galaxy in a humble corner of the cosmos. Its stars tell a history of turbulent change, driven by past galactic collisions and mergers. There are arch trails of stars that are the remnants of smaller galaxies the Milky Way has consumed, and stars that have been flung away at such great speed that they will eventually escape our galaxy to drift through the intergalactic abyss. The Gaia data also revealed several surprises. For example, the Milky Way is not a flat spiral disk like many other galaxies. Its outer edge has a warped shape, which wobbles as the galaxy rotates. This dynamic behavior is likely caused by interactions with other galaxies. Gaia also found that our galaxy is not dominated by two prominent spiral arms. Instead, the Milky Way is filled with a delicate flower of fainter arms. It is also a barred spiral galaxy with a central bulge that is more spheroidal than spherical. And this is just the first detailed view of our home. The complete set of observations will be available through 2 more upcoming data releases, which will give us an even more detailed mapping. Gaia's mission is now over. Yesterday, on March 27, 2025, the ESA's European Space Operations Center deactivated its subsystems and sent the spacecraft into a retirement orbit. All that remains is the data it gathered for more than a decade and the stories that data can tell us.
Astronomy Daily, the podcast.
More than half a year after an empty Starliner spacecraft safely landed in the New Mexico desert, NASA and Boeing still have not decided whether the next vehicle flight will carry astronauts. In an update this week, the US Space Agency said it is still working through the process to certify Starliner for human missions. Whether it is carrying cargo or humans, Starliner's next flight will not occur until late this year or more likely sometime in 2026. Two things stand out in the new information provided by NASA. First, there remains a lot of work left to do this year before Starliner will fly again, excluding extensive testing of the vehicle's propulsion system, and secondly, it is becoming clear that Starliner will only ever fly a handful of missions to the space station, if that, before the orbiting laboratory is retired for good. Several issues marred Starliner's first crewed flight to the space station last June, but most serious of these was the failure of multiple maneuvering thrusters. Concerns about these thrusters prompted NASA to fly Starliner's crew Butch Wilmore and Sonny Williams home on Crew Dragon vehicle instead. They landed safely earlier this month. Starliner returned autonomously in early September. Since then, NASA and Boeing have been reviewing data from the test flight. Unfortunately, the errant thrusters were located on the service module of the spacecraft, which was jettisoned before re-entry and not recovered. Although engineers from NASA and Boeing have worked through more than 70% of the observations and anomalies that occurred during Starliner's flight, the propulsion system issues remain unresolved. To address these issues, NASA said it is finalising a test campaign that will take place this spring and summer. Testing at White Sands Test Facility in New Mexico will include integrating firing of key Starliner thrusters within a single service module doghouse to validate detailed thermal modules and inform potential propulsion and spacecraft thermal protection system upgrades, as well as operational solutions for future flights, the agency said in its update this week. As far as those potential solutions go, one option is the installation of thermal barriers to better control temperatures and prevent overheating observed during Starliner's last two space flights. Steve Stitch, manager of NASA's Commercial Crew Program, said the agency will have a better idea of when Starliner will fly again after these tests and analysis are complete. We'll continue to work through certification toward the end of this year and then go figure out where Starliner fits best in the schedule for the International Space Station and its crew and cargo missions, Stitch said. It's likely to be in the time frame of late this calendar year or early next year for the next Starliner flight. NASA has not determined whether such a mission will carry cargo or crew. The agency's update said that it will depend on the operational needs of the station. However, it seems clear that if there are still some unresolved questions about propulsion system issues, NASA may opt for what would essentially be another test flight of Starliner that also brings cargo to the space station. A cargo flight would effectively be the fourth test of Starliner, dating back to its first mission in December 2019. NASA's update this week did answer one question that had been hanging over the Starliner program. Although Boeing has taken losses in excess of $2 billion on its fixed-price contract with NASA, the company now appears committed to seeing the certification progress through. NASA likely has applied pressure for Boeing's ongoing participation as the space agency desires to have two crew transportation providers to the space station. Yet time is running out for Boeing to make a considerable impact on the crew flights to the International Space Station, which is due to be retired in 2030. Assuming an operational crew flight in 2026, which seems far from a certainty, Starliner would likely fly 4 or at the very most 5 crewed missions to the space station. The initial contracts that NASA signed with SpaceX and Boeing for crew transportation services more than a decade ago had options for as many as 6 crew rotation flights to the station after certification. To date, NASA has only given Boeing authority to proceed for 3 of its 6 potential operational Starliner missions. This milestone is a decision point in contracting lingo where the customer, in this case NASA, places a firm order for a deliverable. NASA has extended SpaceX's commercial crew contract to cover as many as 14 Dragon missions with astronauts. SpaceX, in fact, has now launched 10 operational crew missions to the station. On Thursday, NASA announced the crew for SpaceX's 11 mission. Crew 11, which will launch no earlier than July. Among the astronauts were 2 people previously assigned to Starliner's first operational mission, NASA's Mike Fink and Japanese mission specialist Kimiya Yui. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Xena Cardman didn't have to wait too long to get a seat on another spacecraft after being removed from SpaceX's Crew 9 mission last year. The NASA astronaut is one of the 4 members of SpaceX's Crew 11 mission to the International Space Station, agency officials announced on Thursday, March 27. Cardman will command Crew 11, which could launch as soon as July. Joining her are NASA colleague Mike Fink, Japanese astronaut Kimiya Yui and Oleg Platonov of the Russian space agency Roscosmos. Fink will serve as Crew 11 pilot, and Yui and Platonov will be mission specialists. Cardman was originally assigned to SpaceX's Crew 9 mission. But in late August of last year, NASA removed her and fellow agency astronaut Stephanie Wilson from the manifest, leaving 2 empty seats aboard the Crew 9 Dragon capsule for its September 28 launch. Those seats were kept open for NASA's Butch Wilmore and Suni Williams, who arrived at the ISS in June on the first-ever crewed flight of Boeing's Starliner capsule. Starliner experienced thruster problems and helium leaks on its journey to the orbiting lab, and NASA ultimately decided to bring the spacecraft home uncrewed, which happened in early September. Wilmore and Williams were red-asked to a long-duration ISS mission and put on Crew 9 for the trip back to Earth, which ended with a dolphin-attended splashdown on March 18. NASA has not yet announced a spaceflight reassignment for Wilson.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
The hazards facing lunar astronauts are many. There's the radiation, the temperature extremes, the psychological challenges associated with isolation, and the risk of bad accidents so far from earthly assistance. But there's also dust, which constitutes an ever-present background hazard. NASA has known about the hazards lunar dust poses since the Apollo days. When Apollo 11 landed on the moon, NASA was concerned that the lander would sink into the dust and took various precautions to prevent that. As the spacecraft descended to the surface, it kicked up dust that impaired Armstrong's vision as he piloted the lander. Apollo 17 astronaut Harrison Jack Smith said, "Dust is going to be the environmental problem for future missions, both inside and outside habitats. NASA has developed a method of dealing with that dust that builds up on surfaces called electrodynamic dust shields, or EDS. They tested it on the recent Blue Ghost Mission 1, which was a robotic lander from Firefly Aerospace that became the first private spacecraft to execute a fully successful soft landing on the moon. Martian dust has some peculiar qualities that make it even more dangerous than we might think. It's extremely fine and sharp, and it has abrasive nature that can wear down mechanical components and spacesuits. It can infiltrate seals and, if inhaled, can cause lung damage. There's a serious risk of lung and eye damage if astronauts are exposed to it over longer terms. It has another quality that makes it difficult to contend with. It's electrostatically charged. UV radiation and solar wind constantly bombarding the moon's surface, knocking electrons off particles and creating a positive charge. Since the moon lacks an atmosphere, it can't dissipate electrical charges like Earth can. The dust sticks to everything that carries a charge, and since there's no erosion on the moon, the particles are never smoothed like Earth dust is. They stay sharp. The EDS is designed to prevent dust from sticking, and it uses electrodynamic forces to achieve that. Before and after images clearly show the system's effectiveness. Though the EDS didn't completely remove the dust, it did remove a good portion of it. Dust may not generate many headlines, but successfully dealing with it is a milestone for lunar exploration. This milestone marks a great, significant step towards sustaining long-term lunar and interplanetary operations by reducing dust-related hazards to a variety of surfaces for space applications ranging from thermal radiators, solar panels, and camera lenses to spacesuits, boots and helmets, and visors, NASA said in a press release recently.
For your daily dose of astronomy, space, science, and stuff, you're listening to Astronomy Daily.
An asteroid that's big enough to wipe out a city has a 1 in 43 chance of hitting our planet in the year 2032. But according to new calculations, there's an even smaller chance that it might crash into the moon instead. On February 7th, NASA scientists increased the likelihood of asteroid 2024 YR4 colliding with Earth on December 22, 2032, nearly doubling the odds from 1.2% to 2.3%. The potentially hazardous asteroid measures an estimated 180 feet, 55 meters, across, about as wide as Walt Disney World's Cinderella Castle is tall, and is traveling at nearly 48,000 kilometers per hour. Or about 30 kmph. Although it is too small to end human civilization, 2024 YR4 could still wipe out a major city, releasing about 8 megatons of energy upon impact, more than 500 times the energy released by the atomic bomb that destroyed Hiroshima, Japan. But what if it hurtled into the moon instead? David Rankin, an operations engineer for the University of Arizona's Catalina Sky Survey, revealed in a post on Blue Sky that the asteroid also has a 0.3% chance of hitting our natural satellite. The effects of this unlucky collision would likely be visible from our planet, although we, ourselves, would probably be unaffected. There is the possibility this would eject some material back out that could hit the Earth, but I highly doubt it would cause any major threat, Rankin told New Scientist. That does not mean we wouldn't see it. Rankin told Live Science that, based on current estimates, a collision with the moon could release more energy than 340 Hiroshima bombs. It would likely be very visible from Earth, he said. However, Gareth Collins, a professor of planetary science at Imperial College London, told New Scientist that we would be quite safe on Earth. He added that any material ejected from the collision would likely burn up in Earth's atmosphere.
Well, there we have it for another episode, and don't you feel better that we're all safe from asteroid YR4 and we've got a working dust repeller. I wish I had one here, that's for sure. It's a very dusty old suburb I live in. But that is it for Astronomy Daily this week, folks.
I sure hope you all enjoyed the selection of stories from the Astronomy Daily newsletter.
Yes, a couple of unusual ones today.
That's our Monday episode done and dusted, as you say here, down under.
Yep, that's right, it's in the can and we can all head for the pond for a cool one and a snag.
I'll settle for a recharge and a few bites.
No worries, Hallie, that'll be beaut. And I don't want the episode to finish without a big happy birthday to my big bro Andrew Dunkley from Space Nuts, the greatest podcast on Earth, apart from our humble selves, of course. So happy birthday, Andrew. I hope you're having a great one on the other side of the world. Come back to us safely. Anyway, we'll catch you all next week on Astronomy Daily from the Australian studios down under, just like Hallie said. See ya.
Bye.
Crazy kookaburras.
Astronomy Daily, the podcast, with your host, Steve Dunkley.